Hello everyone and welcome to a new discussion which we are going to have under this groundwater engineering course, and new discussion this groundwater exploration pollution related issues. Not only the exploration as the title says, but the pollution related issues of groundwater, because you see that in recent years, especially I am talking about in India, in recent years this issue has come in a very big way. There are several reasons. One reason is more awareness is there. Government is also bringing legislation everywhere, and very strict legislations are also coming. And secondly, because pollution was increasing in groundwater, and due to overutilization of fertilizers, pesticides, insecticides, and those substances are going in our water system and ultimately are also affecting our crops, animal lives, and of course human lives. Another big reason of polluting groundwater regime is the industries. Many industries in past have been discharging effluent just like that without any treatment. But now lot of restrictions have come, lot of legislation have come, and they are now in place, and all kinds of precautions are being asked by the government for the industry, that they say they cannot just discharge the water or effluent just like that. It has to be treated, it has to be made in a such, it has to be treated to that extent that it becomes almost, for example, drinkable. And I will give you examples of various institutes or places where recycling of water has become very, very important. So the water which is being recycled for mainly for like in IIT Roorkee, if I give the example, you see that the water which is extensively being used for lawns maintenance and this greenery in the campus, it is all now is recycled water which is being used. So this is exactly what government wants. So in many like in IIT Gandhinagar also, they too have installed from day one they are using recycled water for all gardening purposes, maintaining the greenery and other things. Of course, it is not for drinking, but if further processing of water is done or further purification of the water is done, then it can also become drinkable. But if that kind of problem is not there, then it is fine that at least we are not wasting water and we are recycling that water for maintenance of lawns and greenery and other things. So the emphasis nowadays that whatever the water is being used, if it can be recycled, fantastic. If it cannot be recycled, then how it will be disposed or discharged, and that has to be very controlled one. It is not just like that you pass the effluent into a stream or river or nala. So that is why it is very important now to understand what is basically groundwater related pollution and what are the causes, how it can be stopped and how it can be monitored, prevented, so that our groundwater regimes, especially aquifers, and particularly I am talking about unconfined aquifers, which are more vulnerable from these contaminants or these substances. So though we put it as a part of groundwater exploration, and this is one of the spheres or one of the domain of groundwater exploration, and that has received very increasing attention. As I have said earlier, that in recent years this has been a lot of focus on how to prevent our groundwater regimes. So in context of environmental protection, and first of all it is detection, whether the effluent which is coming into our stream system or drainage system is whether it is really polluted or not. If it is, how it can be monitored, how it can be controlled, and how our streams or river systems can be prevented from pollution. So all these are coming in the environmental protection. But a lot of studies are also coming, and lot of understanding is being developed about how these pollutant transport either on surface or in subsurface. So how they infiltrate, how the percolation happens, and how much that pollutants or substances reaches to the aquifers, that is also important. And if it is possible, is it possible to isolate these pollutants, maybe using some plants or some other mechanism by which we can isolate these. So, because we know that these pollutants are downgrading our groundwater aquifers, is it possible also that can we dilute these things so that it becomes safe levels, like if we purify, put some sewage treatment plants STP, and can we recycle that water, which example I have just given. So, all this is now more focused in last 10-15 years, especially I am talking about India, and precautions are being taken. But what about these? See, it is rather easy to control pollution if it is a point source pollution. If it is the effluent is coming from industry, a factory or something, or from a city going into a river, then that is rather easy because we call as a point source pollution. But if it is non-point source pollution, like in case of agriculture, where a lot of fertilizers, insecticides and pesticides are being used, then how we can prevent our groundwater aquifers becoming polluted. So, that is also focus, and very briefly we will be also discussing. So, as we know that in hydrogeological evaluation of feasibility of a site for safe and cost effective disposal of waste. So, wherever if industry is creating hazardous waste or waste which cannot be just disposed like that, then we now we have to study whether the site which we are choosing is really safe, whether the waste or hazardous waste which is going to put on the ground or in a pit or old mines or other things, whether it is going to harm our groundwater aquifers or not. So, for that purpose we have to study the rocks first, mineral composition of rocks, textures, permeability of rocks and their porosity and permeability, and once these things comes, then groundwater engineering directly comes here. So, we have to assess the the hydrogeological characteristics of rocks, where these substances will be put or waste will be put, and whether some important structures, geological structures are there, what kind of formations are there, how the distribution of groundwater is there, and what is the current before even these hazardous waste or any site is chosen for disposal, what is the status of quality of groundwater, that is also now recorded, and every maybe every 5 years or 10 years the wells which are surrounding of these sites are also monitored, especially from groundwater quality point of view. So, these are very important aspects. Now it is related with the groundwater engineering, the pollution aspect, substances which are being put either on surface or in drainage system. So, extensive hydrogeological investigations of pollution problems, basically they requires techniques as we have been thus almost same techniques for a groundwater exploration. That means we have to understand the complete characteristics of formations, what kind of texture is there, what kind of porosity is there, what kind of permeability, and then these sites can be identified for the disposal of waste. You might be also hearing and reading lot of things nowadays. So, with these sites or like a waste disposal which is coming from cities or garbage and other things, and we have around big cities or just outside of big cities we are seeing big kind of a hill which is full of these garbage, and now we call as a legacy waste. So, that is also now have started being treated, and a lot of materials which are being found in that legacy waste is being recycled. So, proper disposal of even legacy waste will bring or will at least maintain a good quality of groundwater, because if you put in the past maybe 20 years back or 30 years back, when these waste sites these waste sites were selected, at that time people probably did not think that this is going to harm, because the related with these waste sites are the leachates, that when rainwater occurs, slowly the water goes downward, and then it whatever the pollutants it is carrying to the groundwater aquifers. So, these leachates are also have become a big problem, and therefore, huge amounts of pollutants are entering through these waste sites or legacy waste sites, and therefore their treatment or their further disposal or I would say their treatment has started. Like in Delhi or in other places, we hear a lot now that whatever the waste was there, the kind of mountains which were created by these waste, slowly it is being removed from there, it is going in certain plants to segregate different kinds of material like plastic, wood, steel and other important materials, and then they are being recycled. So, this is how we can prevent our groundwater regimes or groundwater aquifers becoming polluted, and especially I am talking about unconfined. These are unconfined aquifers are more vulnerable from pollution point of view. So, the analysis of groundwater flow, complete groundwater exploration is required basically. How water flows, because the same way almost the pollutants will also flow. So, analysis of or complete analysis of groundwater flow system which will give us a insight into the possible direction of pollutants movement, and also identifying zones that are likely to be free from pollution, because where the pollutants will move in subsurface conditions, that is one thing, and where are the sites or which are the areas which will remain safe for at least for some time. So, that kind of study is now very much required. So, that will save the ground or prevent our groundwater regimes or groundwater aquifers becoming polluted. Nowadays, before any site is chosen for waste disposal, all kind of studies have become mandatory, especially I am talking about groundwater related. So, first the groundwater related studies are performed or groundwater related similar techniques as for exploration are performed, and then appropriate site is chosen, so that no pollutants from the surface should enter in our groundwater aquifers. Wherever the repositories, where the sites for disposal have to be very safe from groundwater point of view. Let me give you one example here, that what we are seeing here on the right figure are the sources and direction of movement of pollutants that can be interpreted for some typical hydrological conditions. So, we are having in the bottom we are having at the bedrock, and then we are having a confined aquifer condition here. Then we are because this aquitard and bedrock are making our confined aquifer, and then we are having another aquifer which is a ferritic or unconfined aquifer here also. Purged aquifer example is also here. So, if waste disposal well is there, where it should go. So, here like here it is going directly to confined aquifer, but the waste water recharge which is happening here from this pit kind of thing, and that will pollute our groundwater regime. So, people have to think first they have to understand what is the hydrogeological characteristics of an area, and accordingly all these measures have to be taken. So, like here we are having source of pollution. So, source of pollutants is here, pollution is here, source of pollution is here, these circles they are all showing. And if a source of pollution is like this, in case of purged aquifer, immediately it will pollute our aquifer. So, there it is very quickly it will get polluted, but if it is a confined aquifer condition, it might take some time to reach there. And if it is a water supply well and almost nearby, if we are having the source of pollutants, it is going to pollute our the water which is coming in our well. So, these concerns should be addressed, or I would say extensively these should addressed. Situations for each and every location where these pollutants are there or source, we can identify the source, then all kinds of conditions should be assessed there. To what extent we can protect. So, the degree of protection of a site against pollution from surface sources can be evaluated on the basis of hydrogeological regime, for which we again require the same information, same knowledge about surface geology, to some surface geology, structures, characteristics of rocks, porosity, permeability, all those things we require. And of course, the pedology means the soil, if there is a soil cover, that kind of information is also required. Further, we require the zone of aeration, the depth to the saturated zone, and the thickness of the confined layer. all that information will help us to choose a correct site for disposal. Now, there are guidelines are also available, which is a characterization of groundwater flow for near surface disposal facilities. What kind of what kind of precautions should be taken if pollutants or these kind of things are being disposed which is near surface. In many industries it is there. I will give you one example. In earlier time when these coal based thermal power plants especially were being run by the NTPC, so lot of the ash which comes through these plants, because once you burn the coal there will be some ash remaining, and that ash was being dumped in nearby places. So, in some places it was being dumped as dry, but later on it was developed as a slurry, and slurry was coming through pipes and they were coming in these pits where this waste or ash waste was being dumped or slurry was being dumped. And there were no lining at the bottom of these sites. And what happened then? Groundwater regime started getting polluted. So, as soon as people realized that there is now problem, these waste sites, ash waste sites or disposal sites are creating pollution in the groundwater regime, then in at least new sites were selected where a lining of by the thick polythene is being put. Special polythenes are coming. So, that first you line the bottom of that pit at the base, and then you start put these things. But somehow you have to think how to recycle it. Otherwise, for large area you would be requiring. So, then research were done and how this ash can be used. So, people found that if it is 10%, 20% is mixed with cement, and which is now being done, then it will not have any strength problem of the cement. So, many cement plants which were also in nearby such places were started taking fly ash and putting in the cement. Similarly, when we started constructing these concrete roads in the country, for that also lot of fly ash is being used, because after all you keep dumping, but if you do not dispose, even if you are having lining at the base of the pit, but that land goes as a waste, no agriculture or other thing can happen. So, you have to think how to dispose. There are a lot of legacy sites like in city waste disposal and disposal sites, similarly about fly ash sites. But slowly now our understanding is improving and we are going for such kind of recycling of that fly ash, as in case of other polluting materials or municipal waste, as we say, municipal waste which is being segregated, recycled, and even from old sites, legacy sites. So, the requirement or the emphasis for low groundwater flow velocities, so that whatever the pollutants on the surface should not reach our aquifers very quickly. So, we are looking for low groundwater flow velocities and long flow paths, slow down the velocity or can be create a more longer path, so that other reactions happens before it goes to the groundwater regime. So, in many cases it has been best achieved by siting the disposal facility well above purged and regional water bodies. But how you would know about all this? So, you require extensive, or I would say expensive groundwater exploration for the possible sites where the disposal will be disposed. So, if that kind of knowledge is already there or is obtained, then you can probably safely dispose and the waste or hazardous waste or industrial waste, whatever. So, sometimes it may be impractical to place a new facility completely above the water table for climate or geological reasons, because if industry is there, you may not be getting an area at all for tens or 20 or 100 kilometer where you can waste or dispose the waste. So, that can be a problem, but as I have said that if nothing works, then lining can work, but that will create a wasteland also. So, that has to be also reclaimed in future. So, that kind of studies are also required, that kind of focus is also required. So, whatever the facilities, if they are there in existing some site, these are located partly or mostly beneath the water table. The siting of these facilities still requires low groundwater flow velocity as just discussed and long flow path, giving long transit times necessary for radionuclides. Wasting nuclear waste and not harming our groundwater regime is another big problem, and that is also being addressed indirectly here in this part which I have just discussed. Further, we see that many times low groundwater flow velocities imply very complex hydrogeological systems, and in such cases the hard rocks may be very good, because you are only having fractured or a weathered part, and in areas where you are having very thin fractured and weathered part, probably on surface in these areas you can have a low flow velocities, and you can have a absolutely low flow velocity and maybe long path also. Or other ways, if it is relatively nuclear waste, then it is being disposed at a very deep in the ground or maybe in old mines, abundant mines which are in a very solid rocks, and which will not directly will harm groundwater regime unless we go for the groundwater, fetching groundwater at that depth. So, there are many possibilities are there, but the good part is that in recent times a lot of focus, lot of rules, regulations, legislations have come, which will of course will prevent our groundwater aquifers becoming polluted. So, sometimes it is preferred to select a location with a material that is easy to define, that is means the flow path, physical, chemical properties are predictable and to monitor. Monitoring is also very important. You have chosen a site, you have started disposing, but how it is harming, whether it is really harming. So, as I have said that periodically in the surrounding wells, the groundwater quality is assessed, and it is mandatory for any site which is and has been developed for municipal waste or hazardous waste from industrial waste. All these sites are being monitored from the surroundings as well, and not only for water related things, but air related also things. So, air pollution, if a waste disposal site is causing, that is also being assessed nowadays. That has also become mandatory. As we have seen that what are the minimum requirements? The following information should be analyzed as a minimum. What are the minimum requirements? Going for this sufficient details for a site, and like hydrological characteristics of a site may be there. So, if not available, sufficient information is not available, then what are the minimum information which is required? So, first of all, we require identification of approximate geological structures and stratigraphy. So, entire geology of that area is required, and earth scientists or geologists, geophysicists and civil engineers have to play major role here. Location of major recharge areas, from where if we can identify the recharge areas, then we should prevent those areas and we should protect rather, so that no such sites are selected in that area, because these recharge areas will recharge your groundwater regime or recharging groundwater regime, and if it is a disposal site comes nearby, then entire aquifer system, especially I am talking confined aquifer system, will become polluted, and that is a big problem. So, so we need to know minimum information required, that whatever these disposal sites, these areas should not be anyway close to the recharge area. So, that kind of extensive information or hydrogeological information is required. Data on existing and projected major waste water uses, how the water is going to be used, how it is being used, that kind of information is required. And identification of major discharge and extraction points, where it would be discharged, the waste or whatever even the treated water, where it will be discharged, how it will be discharged, what would be the quality of that water which will be discharged, and what are the extraction points. These are the things, so must be kept in, at least these are the minimum requirements before choosing a site, and also estimates the groundwater properties and flow direction and velocity. Because we have been discussing that if we can create a longer path for flow, and also if we can find out the areas where the low velocity is there, those can be better sites. So, that is why this properties, groundwater properties and flow properties are also very much required. Now, in some areas, because suppose some industry has not started putting waste, some site has been identified, but no waste has been put. So, then we can resort to the modeling, and modeling will predict. Basically, modeling are a representation of a real world, abstract representation of real world, stripped version of a real world, and also modeling for predicting what is going to happen in future. And if we predict by doing this modeling, having the groundwater characteristics, flow and everything, then we can use such modeling outputs to make better decisions. If possible, we can choose 3-4 sites initially and then perform the modeling. And if we find that a particular site will create minimum pollution into our groundwater regime, then that site should be selected. So, the decision making process becomes much wiser, much better, appropriate, largely will, and these decision making systems will depends on the level of existing hydrogeological information. And that is why in the beginning or even here we are putting heading as pollution related exploration, because we are not really in environmental science directly or in waste disposal. What we are looking that how these processes or waste disposal and other things will harm our groundwater regime, and for that how we can help them. So, for that we have to do this kind of study. Basically, it is a typical hydrogeological exploration which has been done, or hydro or geophysical exploration. Complete knowledge about that area related with groundwater has to be there, not only the quantity but quality also, and the existing one. So, in particular this information, sufficient and similar level of data must exist for each candidate sites, possible sites. If we have identified 4-5 sites, then we should have all almost same level of data, then only the better decisions would be made, because the modeling is only for that purpose. So, so that the candidate sites or possible sites can be included in the same extent in the modeling exercise, and modeling results for the various candidates sites are comparable reliability. So, whenever you are comparing, then you have to have almost the same kind of treatment for all those. So, in this modeling you would be having, so it is always modeling is done. If there is no choice, then only for one site, then that cannot be a very good decision. But if it is possible on 3-4 sites, one site can be chosen which will create minimum pollutants or will create minimum pollution to our groundwater regime. So, these identification of these sites are suitable for further evaluation, may be evaluated further for groundwater flow modeling, and then evaluate the average groundwater velocity and flow paths also. So, more refinements in our modeling can be done, focusing on groundwater flow also. And these two parameters, the flow velocity and flow path, are indicators of travel time of radionuclides and other solutes in groundwater. Here we are mentioning radionuclides, does not mean only this. For all kinds of polluted related ground exploration, all this information is very much required. Now, what are the stages of investigation which are related with groundwater related pollution? That one or more possible sites or candidate sites to be determined if they fulfill safety and environmental requirements, and these environmental requirements and constraints are becoming larger and larger. So, we need better understanding about each possible site. So, this stage is required for both existing and new facilities, and existing I have been mentioning about legacy sites. So, because all the information related with legacy sites may not be possible, because the old data about the groundwater quality, water table and other things may not be available when that site was chosen. But anyway, for new sites all that information should be collected, and then appropriate decisions after modeling should be done. So, in case of existing facilities, site characterization may be used to supplement available data. Further refinement of the models and better understanding of the behavior of groundwater flow if remedial measures become necessary. So, even if an existing site is there, again whatever the possible investigations are can be done should be done. So, that we can understand how much pollution that site is coming, and that is why after going through several such studies, then at big places like I gave the example of Delhi or some other parts, that the legacy sites are now being chosen to do the recycling work, and these meter by meter the waste is being removed, going for the plant for segregation, for recycling of whatever the materials which are coming out of that. So, several stages are there, but in this particular stage, in the initial stage, in the exploration stage, the following information relevant to groundwater flow transport should be obtained indicating below. More detailed information on the geological structure in stratigraphy. So, in the previous just before that we have discussed the minimum requirements. Now, we are discussing more detailed requirements. So, detailed information on geological structures in stratigraphy, location, extent and interrelationship of important hydrogeological units in the area. Units, say hydrogeological units, means what are the formations they are there, or maybe aquifer conditions and other things, average flow rates and prevailing direction of groundwater flow. So, flow direction and flow velocity, that kind of information is always required. Now, this is another very important thing, as we have also discussed earlier, the recharge and discharge of major hydrological units, where these groundwater aquifers are getting recharged. Can we avoid those areas for any kind of such selection of these sites, not even for any waste disposal. So, that is another very important information required. Regional and local water tables and their seasonal fluctuations. Seasonal fluctuations here means basically from Indian terms is pre-monsoon and post-monsoon. So, that kind of, what are the regional water tables are there, what is the local water table is there, and for any new site all these things are nowadays recorded in different reports, and in periodically these are things which are checked again. So, whether the groundwater quality is getting deteriorated or water is getting polluted, if at all, then stringent measures should be taken to prevent our groundwater aquifers. And also it is very much required what is the site topography. In recent times or in few months back, I have visited one site in Faridabad which was for hazardous waste, which was coming from some industries in Haryana, and they have chosen a old this quartzite mine, which was an open cast mine, and whatever the waste which they are putting, before that they are putting over a thick polythene layer. So, at the base of that pit, open cast pit or mine, they have first put a this thick polythene layer, and over that it is being put, because that waste cannot be further treated or further recycled. But that is based on the current technology, current understanding about the waste material. But maybe in future that site can become legacy site, and maybe in future we may have technology by which we can take out that waste which is being dumped today, and we will start extracting precious metals, because that waste is also containing lot of precious metals which are coming from electronics components. So, in future the technology exists, but currently it is not economical, it is very expensive, but in future the new technologies can come which will allow us to segregate these precious metals which are being used in electronic components, and then we will be able to, for time being it is being dumped there, but at the bottom of the pit we are having a thick line of polythene. So, further we require for detailed things and detailed understanding of the site characterization, we require the existing and plant surface water bodies, because the nearby surface water bodies have to be studied. There the quality, of the water has to be studied. So, definition of areas containing poorly drained materials, that is also there. Data on the flood history of the region, that is another problem. So, that has to be understood before any site is chosen for waste disposal. Then meteorological information, what kind of rain we are getting, precipitation, evapotranspiration, extreme weather phenomena and hydrological balance. What I am trying to say here, that extensive knowledge is required before any site is chosen for especially for hazardous waste. Even for municipal waste, extensive requirements are there. Then only those sites should be chosen. In past, whatever has happened is fine. Now it is that legacy waste is being treated, but for future, so that we can really prevent our groundwater aquifers from all kinds of pollution. Especially what I am talking about, point source pollution. In non-point source pollutions, there will be some other kind of measures. So, parameters of flow and transport, which we have been discussing, soil moisture profile, that is another important aspect, hydrogeochemical characteristics of the site, interaction with the facility, and finally existing and foreseeable water and land use, how that water will be used, and how much, if water is coming, how much water can be recycled and so on. So, in case of new sites, which more or less we are talking here, the site confirmation stage is conduct detailed site investigation at the preferred site to support or confirm the selection, provide additional site specific information which might be required for design, safety and environmental impact assessment and licensing, because once the site is chosen, it has to be cleared from environmental ministry like in India, and then they will look all these aspects, and then environmental clearance, or we say license, can be given. So, for existing near surface facility, what are the things which are required? The determination or confirm by continued monitoring analysis whether the site is suitable. So, this is another important thing which I have been also discussing earlier. Continue monitoring, periodical monitoring is very much required, it is mandatory nowadays. So, it is suitable for further disposal, and in case of post closure, suppose a site has been closed now. So, it has to be further, it is not just closed and gone, no, it has to be assessed for deviations from the predictions of groundwater flow model, and provide additional information for safety and environmental impact assessment to support continued licensing. Because a site has been closed, but still it may harm the groundwater regimes. So, related with this, what are for the site investigation, what are the aspects and techniques which are available. So, for, on the left column we are having aspect to be investigated, and whatever the current available techniques which are there in this table. So, for geological information, which we have been extensively discussing in under this hydrogeological exploration, but very briefly here, that aspect to be investigated in case of a site for such waste, that geological structure, stratigraphy and other things. So, of course, you require mapping and maybe understanding subsurface geology and borehole drilling and other things, if it is not available, that kind of information. Geological materials, geochemistry, geophysical methods can also be employed, geomorphology and topography, that is also required, that can be assessed through the remote sensing or some other methods, maybe topographic maps and other things for the topography. Then hydrology is related thing. So, we need the meteorological data, precipitation data, temperature data. For that, maybe some rain gauge station for a possible site has to be installed, temperature measurements. If that kind of detailed information is not available by a nearby meteorological station, then exploration about evapotranspirations. So, what kind of information, that is, if it is not available, it has to be collected before a site is declared for waste disposal. Similarly, whatever the rocks which are present in the medium basically. So, in subsurface conditions, so we have to understand the texture of rocks, infiltration capacity and retention capacity of these rocks. So, these kind of informations are required, which can be collected through laboratory methods or field based methods. Then hydrogeology, which includes again hydraulic conductivity, transmissivity, specific storage, porosity, all those basic hydrogeological parameters or characteristics of these aquifers are required. And similarly, in moisture content, dispersion, diffusion, retention, water potential, recharge and discharge site. This I have been mentioning about. This is very, very important. No recharge site should ever be chosen for any kind of waste disposal site. Simple is this, because it will directly pollute our groundwater aquifer, whether aquifer is a confined or unconfined. So, that kind of study or knowledge about that area is very much required, for which you need to have a geological mapping, water balance, isotopic studies, hydrogeochemistry, all kinds of things. Recharge and discharge sites, in that you need to know the water balance, isotopic methods, tracer determination, seepage, hydrograph and all kinds of things. Flow velocity and direction, that is another important thing. Once the site is chosen or about to be chosen, then what kind of flow velocity is there. Our aim to delay the flow. Our aim is to have a long path for flow. Our aim is to have low velocity for the flow. So, that for what kind of techniques are available, that is also here. Then residence time, what is going to be the time it will take, and so that is can be isotopic based or hydro geochemistry based. Further, in hydro geochemistry, major ion geochemistry study is required, which can be done through samples collected and investigated in the laboratory. Then physico-chemical parameters, again field methods and other things, environmental isotopes which can be done. So, what we have discussed here, that when we talk about pollution, it is very, very important from groundwater regime point of also to prevent our aquifers from all kinds of pollution, whether it is a point source pollution or non-point source pollution. Most of our discussion in this was mainly based on the or was focused on point source pollution. But very briefly, before I end this discussion on non-point source pollution. So, if we can, as being done nowadays in lot of places, so less usage of water, the crops which requires less water are being promoted. So, if you put less water, less fertilizers, less insecticide, that means directly you are saying less pollution to groundwater. Maybe change in crop cycle, maybe different kind of crops which does not require much water. So, with this we can probably prevent our groundwater aquifers from becoming pollutant. So, with this I thank you all.